Hello students, welcome to Power Tutorials. So today we are going to cover part 1 of Science Class 10 CBSE, that is NCERT textbook, and the chapter is chapter 9, which is light, reflection and refraction. And today we are going to cover regarding plane mirror and a concave mirror few topics. Okay, so this is part 1. In the previous video I have covered part 0, and that I have explained as a live session. So there I have explained how the object can be seen and why we cannot see objects in cave, what is a basic mirror, types of mirrors. We have covered plane mirrors, spherical mirrors, and I have also explained in depth like how the hollow sphere has been cut can be made to form of a concave or convex mirrors. And then we have covered the basics of reflection, and those anyway we'll cover in this chapter in detail. And we also covered what are the lenses topic as well. So I suggest everyone who are seeing this video to check my part 0 first, because that will be having a broad understanding like about what is lenses, what is mirror and all in detail with help of diagrams with colors I have also explained. So if you're interested, you can check that part. Okay, so but today video is part 1. So here we are going to cover as it is, which is there in the textbook, and also I will also give few examples like real life examples which you can relate and you can understand easily. Okay, so the chapter first topic is you have to understand what is a plane mirror. What is mirror and all I'm not going to explain in this part because those are already covered in part 0. Okay, so for plane mirror we need to understand few things, so I'll just point out those points. So plane mirror is one side is polished and other side is rugged. So what happens if a light falls on a plane mirror? Suppose this is a midline. Okay, so just take a line and just draw a line, and if I keep an object here, so this I am representing as object A, B is object, and this is just a horizontal line which is like I can also see the line which is perpendicular to the mirror, we call it as normal. Okay, so this we covered in the last class as well. The line which is perpendicular mirror is called normal. So in this normal, if I say that AB is an object, so what I will get is it will form, if I just project it backward, it will form an exact image at the virtual side. So we call this as let's mark it A dash B dash. Okay, if AB is the object, then A dash B dash is image. Okay, what about if I say this is D, then we'll also get the same distance D here. So the first point, distance of object from mirror is equal to distance of distance of image from mirror, or else simply I can say distance of object is equal to distance of image. Okay, second point, size of object is equal to size of image. So I can say that size remains same and distance remains same. What is the nature of the image? Nature of image is virtual and erect. So this you have to remember, virtual and erect. You can see that the image is virtual, I mean erect. If it is inverted, then we call it as inverted, but here whichever AB is the image, object, A dash B dash is the image, so it is on the same line and the size is same, and it is a virtual image that it is forming behind the mirror. Okay, so these are the things which you have to remember for plane mirror. Okay, and then the next topic is laws of reflection. So this is applicable for every mirror. Okay, so what are the laws of reflection? You have only two laws. The first law is angle of incidence is equal to angle of reflection, and how they are considering, we are considering with respect to normal. With respect to normal, this point is important. Why? Because if I say this is the mirror And what is the normal? Perpendicular line. So this is the normal. Then this line, if it is called as incident ray, and this will be theta I, and with respect to normal you will have a reflection, and this is nothing but theta r. So theta I is equal to theta r. Don't say these are equal. Okay, only these are equal. With respect to normal, the angles are equal. Okay, second law, incident ray reflected ray and normal all lie on the same plane. So it's not like in one plane we have incident, in one plane we have a reflected, in one plane we have normal. All the three rays, this one as well as this is the normal, all should lie on the same plane. So this is very easy, and this is an important question for 2 marks question as well. They can ask you, mention the laws of reflection. You have to mention these two. First one is angle of incidence should be equal to the angle of reflection with respect to normal. The same way, the second point is incident ray, reflected ray and the normal all lie on the same plane. Okay, so this is respect to plane mirror. And what is the object, the image characteristics by plane mirror? Its size is same, distance is same, nature of the image is virtual and direct. Okay, now we are going to talk about the next topic, which are spherical mirrors. Okay, so in the part 1 I have explained what is concave and convex and how those mirrors are created. Okay, so now I am not going to discuss how they are created. Just I will start with the basic diagram of both the mirrors. So this is polished and this is rugged. So this will become convex mirror, whereas this is polished and the other side I am taking it as rough. So inside is polished, then we call it as concave mirror. Okay, so these are, we have two types of mirrors, convex and concave. Convex, the outer surface is polished. Concave, the inner surface is polished. Okay, so don't say these lines are polished. Lines are the rough surface, which is not having any line is the polished surface. Okay, now we are going to cover few terms related to spherical mirrors. So this we covered, but still this is important for part 1 as well, so I'm going to cover once again. So I'm taking both the mirrors. Okay, so this is convex and this is concave. So what are the parts we need to remember, or the terms? First one is pole. This is pole. Okay, pole is the center of the mirror. And then, so first if I say this is AB, and let's mark this as CD, then AB is called aperture of mirror. And this is nothing but the diameter. Okay, AB, as I mentioned, it is the aperture, and this is for convex. The same applicable for concave as well. So here CD is nothing but the aperture of concave mirror. Okay, then we have, if I draw a line, imaginary line like this through the pole, so there will be a point where we can assume this forms a sphere and it will have some center. So that C is nothing but the center of curvature. Okay, same way here also we can imagine somewhere this will form a sphere here and it will form is C, which is nothing but the center of curvature. So then we have another point called focus, which is capital F. Here also we'll be having some focus. So this focus, one more, distance CP is called radius of curvature, And now we are assuming that aperture, that AB is much lesser than the CP. If AB is much lesser than CP, then we'll get a focus point which is nothing but midpoint of C and P. Okay, so I will write in here, this is R and this is F. Here also I will write, this is F, which is nothing but focal length. This is R, which is nothing but radius. Okay, we have covered. I'll just underline with another color. We have one which is aperture, and then we have center, then we have CP, which is nothing but radius, then we have F, which is nothing but focus, midpoint of C and P, and we have R and we have F. Okay, hope you understood all these terms, because these are important when you are drawing any ray diagram and you are finding the image of the object of convex or concave mirrors. Okay, so let's understand most detail about why F is called focus and why it is exactly at that point. Okay, so for this, what I will be taking, I will be explaining for both. So I will explain for concave first. So if I take a concave mirror, and if I keep a white sheet of paper exactly at the center which is passing through pole. Okay, now keep it open through a sunlight and keep it open for some time. What will happen means, the sun rays will be falling here parallelly to the mirror. Okay, let's assume if we keep it exactly on the direction of sun. Okay, so this way I'll just change it and assume that we have kept somewhere here, so that this is sun, not mirror. The sun direction, if I kept like this, the rays will be falling towards the parallel to the mirror. And what will happen means, if the rays are falling parallel to the mirror, suppose this is C, then at some one point you can feel that the flames will be coming and that piece of paper will be burnt. Okay, so that part is nothing but the point where the light rays, everything is getting reflected, which is nothing but focus. Okay, so focus is the point where all reflected rays will get coincide. And the incident rays should be parallel here. Incident should be parallel. Okay, same applicable for convex mirror as well. So if I take a convex mirror, it is like this, which is shaded from inside, polished is outside. Okay, so if the same example, if I consider the sun is here, this is sun here. Okay, so if I pass parallel lines to the convex mirror, what will happen means, all these lines will be reflected. At the same time, they will appear to be coming from a point which is here. So it will be reflected in this way. Got it? So all the incident rays will be reflected in such way that they appear to be coming from a point which is exactly at this point on the mirror, on the sheet of paper, which is called as focus. So this is center and this will be pole. Okay, so we have to remember two things with respect to spherical mirrors. 2 points with respect to spherical mirrors. No, 2 points, I think 3 points. for ray diagrams. So what are those? First point, point 1, if the incident ray is parallel to the mirror, or instead is parallel to principal axis, I can say that will be better. Principal axis, what will happen? Reflection or reflected ray will pass through focus. Okay, so this we already studied, so not going to explain it. So small diagram I'll draw it here. I'll use another color for better make it interesting. Okay, let's use orange color. So if I have a mirror like this, concave mirror, then if I say this is the principal axis is a line which is normal, again perpendicular to the whole mirror. Okay, normal is different, principal axis is different. Okay, so this is passing through pole. So if I have a line like this, okay, I'll change once more. So this is incident ray. Then I will have a reflection which will be somewhere here. This will pass through focus and these two lines are parallel. This is incident ray and this is principal axis. Okay, same applicable for convex. I'll draw the mirror first. Take the incident line, take the reflection. This is focus here. Okay, so the incident ray, if it is parallel to the principal axis, what is happening? The reflection is passing through the focus. Second. So now we can just reverse this first point, like if the incident ray passes through the focus, then reflected ray is parallel to the principal axis. I think everyone understood what I want to, so I'll draw it again. So we have a concave. So to the concave mirror I will draw a line which is passing through focus. Now the incident ray is like this. This is the incident ray which is passing through focus. What I have told, the reflection is parallel to the principal axis. Now I will get a reflection like this. The direction is important. This is incident and this is reflected. Okay, same applicable for concave mirror, because I told you the same rule applies for both concave and convex. So this is convex mirror. Let us have an incident ray. This is incident ray. Wait, incident ray I told you it should pass through focus. Okay, so let's keep a focus somewhere here. Okay, now I have incident ray like this. Then I told you the reflection is parallel to the focus, parallel to the principal axis. This is incident ray and this is reflected. You might be wondering why it is not passing through focus. No, it is passing through focus, but as focus is on the other side of the convex mirror, so we are just assuming exactly if it is passing on focus, what will happen. Okay, here you can see in concave it is focus is left side, so it will fall through focus, go to the mirror, hit the mirror and get reflected, which is parallel to the principal axis. This is principal axis. Okay, and the third point, the incident ray Okay, we have fourth point as well. Fine. The incident ray reflects exactly as plane mirror when passing or when hitting pole. Okay, so if I say I have a mirror, concave mirror, where is the pole? This is the pole, center point. Okay, so to this pole, if the light rays, incident rays falling on the pole, then it will get reflected exactly as plane mirror. Why I am saying plane mirror? Because the angle of incidence and angle of reflection will be same. Same as here, if I take convex mirror like this, shaded on the inner side, this is pole, take the incident ray, then I told you the reflected is same. This is reflection and this is incident. You can see that the ray is exactly same for both the mirrors. Okay, if it hits the pole, only in this case both the light rays will be exactly same. You can feel the both are same. Okay, we have one more, fourth one I missed it, so I'll just try change the number. It is 4, not 3. The fourth one, if the incident ray passes through center, what will happen means it will get reflected in the same path. Okay, so simple. What I mean to say that if I have a concave mirror, draw principal axis, now draw the incident ray. Okay, C is here. If you draw incident ray like this through the C, and if you hit the mirror, what I mean to say, then the reflection is on the same path. Both are on the same way. Same as for convex mirror. So if I have, so here the C will be inside, this will be C. Okay, so if I have a line which is passing through C, then I told you it will get reflected in the same path. Both will be on the same. So however it is coming and hitting the mirror through the center, then at the same time what will happen, the reflection will be again back to the same center and it will go back. Okay, so those are the main 4 points which you need to remember while you are explaining any such things with respect to the ray diagram. Okay, the first one is, if it is parallel, then it will pass through focus. Second, if it is passing through focus, it will be parallel to the mirror, parallel to the plane axis. And third, if it is if it is hitting pole, it will be same as the reflected ray as a plane mirror. If it is passing through center, it will get reflected in the same path. Okay, now using this, we are going to get the images of a concave mirror. Images formed by concave mirror. So this, by this topic we will close for today. So let 25 minutes. Okay, we'll try within 5 minutes. We'll try to cover at least 2, or else we'll try to complete it and then we'll close, and tomorrow we'll start with the convex mirror diagrams. Okay, so first image. So first of all, at least understand how the image will be formed. Image will be formed when two reflected rays are met. Remember this. Image will be formed where two reflected rays are met. Okay, the first ray diagram is what happens if the object is at infinity. If the object is at infinity, what will happen? So same way I will use orange color. This is mirror, we have the principal axis, and this is a rough surface, whereas inside is plane surface, I mean the polished surface. So we'll have the points to be marked. We have center, we have focus, and then we have pole. Now let's draw the incident rays. So before that I will use another color for object. I'll use red color. Okay, if we keep the object at infinity, so here let's take this as an object. Okay, I'll use another color. Okay, let's use this one. This is object. Okay, it is at infinity. So if it is falling from infinity, we can take rays, incident rays, purple I'm using, pink. So incident ray is this one, which is parallel. Let's make another incident ray which is parallel. Let's make third incident ray which is parallel. So we have so many incident rays. So at least we'll take only two. So first I told you the first point, if the object, okay, this is object. If the incident ray is parallel to principal axis, what I told you, the reflection is passing through focus. Simple, I will take this one passing through focus, and if I take second line also, it is passing through focus. So where the image is created? Here the image is created because both the reflected rays are connecting at this point, and this is object. So what about the image now? Image properties, if I ask you, you have to say the image properties are, first point, size is diminished or point sized. What is the position? Okay, I'll write nature also. Nature we call it as, it is, I mean, to the face of the mirror, so it is real. And we call it as inverted, but I can don't say it is inverted also because it is just a point. Okay, so we say it is inverted because it's not virtual in that case. Okay, and then third case, size, okay, position, where the image is formed, it is formed at focus. Okay, in this, the first point is done. Object is infinity. Let's do the second one. If the object is beyond C, not at infinity but beyond C. So let's try the mirror again. So we have a concave mirror, principal axis, this should be rough side, we should be having center, we should be having focus, and this is pole. Now I am keeping the object here. Object at all, I'll use this. So now I am pasting the object here. So AB is the object. Now let's try in the incident rays. So incident rays, mostly we will choose either focus or center or pole because we know all the reflections how it will happen. Okay, the first ray I will assume is I will take one parallel line which is parallel to the principal axis. So if it is parallel to the principal axis, I know the variable the reflection, it will be passing through focus. Okay, I'll change the color. This is the reflection. I'll take another line which is passing through center as another incident ray. If the ray is passing through center, what will happen? It will be parallel to the principal axis. Sorry, through the center means it will get reflected in the same path. So this is incident ray and this will be the reflected ray. It will be exactly same. Okay, so both the reflected rays are getting combined with point at this point. Now the image will be created here. This is image, so this will be A dash and this will be B dash. Okay, what about position of object? I told you it is beyond C. Let's write about images. We'll follow the same order which we covered in the last point. Size, nature and position. Okay, so first one is size. What about size? It got small. I can't say diminished, but yes, it is small than the original size. Second, nature. If you notice properly, it is inverted because object is above the principal axis, but we got the images below the principal axis. It is real image and inverted. What about position? Where it is formed? Position is between C and F. Okay. Let's solve third one. At C, at center of axis, center of curvature. So again, concave mirror, principal axis, and this is concave, so one side should be rough, other side should be polished. We have a center, we have focus, and this is pole. We have an object at the center of axis, center position. Okay, let's suppose this is object. Okay, and this I will mark it as A, B. Then we need to have two incident rays. So for this, first every time I told you I will always consider the first line as parallel line, which is parallel to the mirror principal axis. I will get the reflection through focus. Okay, and where C is covered, so you will not check C now, but we will use focus. So now I will take the another incident ray which is passing through focus, and as per the second rule, what is if the incident is passing through focus, it should get reflected parallel to the principal axis. Okay, now this is the image. This is C, this is image. So image points I'll mark it as A dash, B dash. Okay, this you have to draw it with a scale and pencil, that will be much better, but still as of now I'll just write the image properties, size, nature and position. So first one, size. If you notice at this point, the size will be exactly the same as that of object. And then what about nature? Is same as previous, which is real and inverted because in inverted position. Then what about size? Size nature is done. What about position? Where it is formed? It is formed exactly at C, but reverse, inverted. Okay, let's move to the fourth point. If the object is between C and F. Okay, again let's draw the diagram. So concave mirror, principal axis, this should be rough surface, then we have center, then we have focus, we also have pole. Now I told the object is where it is between C and F. So here we have the object, and let's mark it AB. The first I told you, always I consider the first incident ray as parallel to the principal axis, and it will be reflecting. How the reflection? If it is parallel to the principal axis, it should be passing through the focus. Okay, so the second ray you can also write passing through focus, but if I do passing through focus, at bottom it is coming and it is getting reflected. You can do in this way, but in the textbook what they followed is they have done passing through centers, they have done it. Okay, also follow the same method. Fine. They use small objects, so I'll just change it, but the concept will be same. If I use a smaller object like only this much, okay, if it is a smaller object, then the first part will be same. Instead parallel to principal axis, it will be passing through focus, and if it is passing through center they have used, so we'll do the same, because invigilators in the exam center they prefer NCERT textbook concepts. Okay, let's take instantly passing through center means somewhere here. If this is passing through center, then I told you the reflection will be the same direction. Got somewhere here. Okay, so now if you notice the size of the object and size of image, so this is image, which is A dash B dash. So now if I write about image properties, first size, now it got enlarged. Second, nature, again it is same, real and inverted. Third, position, now if you notice the position it is moving back, now it is beyond C. Okay, the next position at focus, between C and F is done. Now we have at focus, same way let's draw the mirror, principal axis, then we have focus, center and pole. Let's take the object at focus, so this is the object which is AB. So first incident ray parallel to the principal axis, reflection has to pass through focus. So this is the reflected ray, and then we have second, we cannot have it, so I will use the from the center again. So center I told you, if it is passing through center incident ray, the reflection will be exactly on the same path. So if you notice here, these two rays are not getting intersecting, we can't even imagine where they are intersecting. Okay, so this way what I will assume it, that the position of the image is at infinite. Okay, and where they have connecting, that size will be the image size. So this way as we cannot predict, we will simply say the first one, size, I'll mark it as enlarged, or infinity also you can say, but we'll see too enlarged if possible. Okay, and nature, it will be again same, real and inverted. Last one, what about position? We say it as infinity, because we don't know where they're getting combined. Okay, now we have the last one, sixth position. If we keep the object closer to P, or else I can say simply, if the object is between F and P, so same method, let's take sorry, write it neatly again. If it is between C and P. So first step, take a concave mirror, principal axis and all. Let's draw it first. This is concave mirror, principal axis, rough surface, center, focus, P as pole. Now what I have told you, I am keeping the object between F and P. I'll take a small object, and this I mark it as AP. So if I draw parallel, then should has to pass the focus. So now the incident ray will be cutting the object. So instead of that, what I will do is, the first one is same. I will simply use the one which is parallel to center again, because I don't want to cut the object and get the image. Okay, so this way the incident is passing through center of the mirrors, then we'll get the reflection which is exactly same as the center passing through center. Okay, we got one ray which is this one, and we have one more which is nothing but, if a light ray is passing through pole, I told you this, so what will happen, the reflection will be exactly same as the same plane mirror, which will be exactly downward. Okay, now these two will never intersect, because this is going the other one and this is going downward. But if you project it backward, so like this, if you project it backward, I can say that somewhere it will intersect at back side of the mirror, and this will be the image. We call it as A dash B dash. Now let's write about the image. Why I have projected backward? Because I want at some point they should get intersected. This side it cannot get intersected, so I will use this side, back side, so that I will assume that back of the mirror they will get intersected. Okay, then what are the properties of this image? First one, size. So here also I can see the size got increased, so enlarged. Position, sorry, second we are talking about nature. Nature, here you can see the image is created behind the mirror. Behind the mirror you always consider it as virtual image. And is it inverted? No, it is on the same side, so it is erect. Okay, then we have size of the size is done. Position of the image, it is behind the mirror. Okay, so till here I will stop the class, because it will get overflowed. So just read which are the topics we have covered today, like where the position of image object is placed for a concave mirror, how the light rays getting reflected, and how the image is getting created. Okay, in the next part we are going to cover images formed by convex, and we will also cover, if possible, what are lenses and refraction. Okay, so these three topics will be covering the part 2, and in part 3 we are going to cover the light rays or the images formed by the lenses which are concave and convex lenses. Okay, so make sure to if you like this content, please do like. If you have any doubts with respect to the content explained today, kindly mention in the comment section. And part 0 video, I'll keep it in the description. So if you want to check about what are the prerequisites I told you, you can also check that part. And if you have any doubts for that video also, you can also mention in this video as well. Okay, so thanks for watching. Let's meet again in part 2.